name is Yuichi Greywright, and I'm going to be talking on behalf of Solitaire Spade Science, and is this is Physics Lesson 2. What's going on? Hold on. Okay, sorry, not my mouse, my thingy wasn't. The mouse wasn't working. And today we're going to be talking about gravity. Okay, so hopefully you all know what gravity is, but in case you don't, gravity is basically the attraction of all matter. It basically is the force responsible for. It's the reason why all masses are attracted to each other. And we know from Newton's third law that they're attracted to each other. The force is the same. It's the same amount of force. The larger mass is exerting the same amount of force as on the small mass as the small mass is to the large mass. Okay? So, and we also recall from the last video that force, because gravity, I said that it is indeed a force. And we know that from the last video that F, force, is equal to mass times acceleration. And gravity is indeed a force. I'm repeating myself, but I just want you guys to know that gravity is a force. So, and mass for the most part is constant. So we know that there must be a gravitational acceleration. And so these bodies are indeed accelerating toward each other. And so in this video we're going to try to find out how to solve for the acceleration, okay? So the first thing we notice about gravity is that if we have a very large person and we have a very thin person, then this guy will be pulled down to the earth more than this guy. This guy has a higher gravitational potential energy. And we're also going to get into potential and kinetic energies right now. So basically the difference between kinetic and potential energies are that kinetic is basically the energy you have while you're in motion, okay? And potential energy is basically the energy, like for an example, if you have a ball on top of a bookshelf, then it has a gravitational potential energy. It could potentially fall toward the ground, and in a sense it is, but there is another force acting against it, which makes it seem like it's not, but that's potential energy. And the only thing that's keeping us from falling to the center of the Earth is the Earth itself, and it uses electrostatics to keep us up, and we're going to get into that later in the series. But, so, yeah. So, we know that that weight, gravity, is caused by mass, hopefully. So we will have an m. We're going to make an equation, okay? So we know that the strength of gravity is caused by mass, so we're going to put an F here is equal to this mass. And then and we also notice that if we were to go out into orbit, or not out into orbit, but if we were to go kind of far away, See, gravity, if you go into orbit, gravity is still having an effect on you. If you go 20 billion light years away, the gravity of the Earth is still having an effect on you. It's just a lot less because you are further away. So we're going to put that in our equation. And usually, or not usually, but in this equation we're going to put distance as r, and you'll see why. And in fact, the gravity weakens by the square of the distance between you and the Earth. So it would be distance squared. So m divided by distance squared. Yeah? So if you went outside, and if you tried to, and if you happen to know the mass of the Earth and the distance you are from the center, then you could potentially solve, well, not yet. You wouldn't be able to solve for the acceleration of gravity yet. Because you would realize that your answer doesn't make any sense. I've never actually tried to do it without because there's actually a constant in here. It's donated as g, and g was first derived from Newton, and it is the universal gravitational constant. Okay, that's what it is. The gravitational constant, and the gravitational constant, I don't remember exactly what it was. It was approximately, so g is approximately it was 6.67, what was it, 3 times 10 to the negative 11th. Some units, it's weird units. I don't exactly remember what it is. I don't even know if this exponent is correct. I'm pretty sure that's what it is, though. Yeah. So basically what we would do to find the force, the acceleration, this is actually just the acceleration of gravity is equal to the gravitational constant. This number, it's just a constant, never changes, multiplied by the mass of the planet or the body you're being attracted to, divided by the distance squared. Okay? And that's the acceleration. And then we can multiply all of this by m to get the force. And this finds the potential energy of the system. So, like, for this, you would find how fast you would, if you were to jump off the roof. If you exclude the mass, your mass, so if you were to jump off of the roof of your house, then you would fall at approximately, acceleration is approximately equal to 9.82 meters per second squared. And remember, we have the squared there because it's accelerating, as forces tend to do. So yeah, and we can actually solve this equation to find this. Okay? So basically, if you want to find your weight from this, then all you'd have to do is take, because this is the acceleration, you would just multiply this 9.82 meters per second squared. You would just take that and multiply that by your mass, and that will equal your weight in newtons. And your weight is gravitational potential energy. So, that's interesting. So at the beginning of the year at my school, we were doing um, we were doing the we were trying to find the difference between weight and mass, or the most of the kids were. See, and they had to use these they had to use the we had two different weights. We had one that weighed by mass, and the other one weighed by weight. We had two different scales, and we wanted to find the difference between, because most people would think that mass and weight are the same thing. They're not. And so, yeah, see, I didn't do that. I completely ignored that, and I just used this equation, and I got all of the questions right. Yeah, I got all of the questions right on everything that we did. And see, what I would do, they would ask for the weight. They would give you the weight of an object, like a golf ball, and then they would have you find the mass of the golf ball, but not using the equation, using tools, using the scales, and yeah. But I ignored the tools and used the equations. I just took the weight and divided that by the acceleration. Actually, never mind. I shouldn't have scribbled that out. 9.82. Ignore that. And then I got the mass. And this can be rewritten as the force divided by the acceleration equals mass. And we just rearrange this to get F equals ma. Okay? So if you ever want to know how massive you are, quite literally, you would take your weight, divide that by the acceleration, and you'd get the mass. 9.82 meters per second. And we are going to use this to solve other things in the next video. This has been Yuichi Greywright, and I am signing off.